Imagine a time before time, over 4.5 billion years ago. The universe was a vast, dark expanse filled with the potential for creation and destruction. Our solar system was a swirling cloud of dust and gas, a cosmic nursery where stars were born. This nebula, a remnant of previous stellar explosions, held within it the seeds of planets, moons, and the sun itself. Gravity, the invisible hand of the cosmos, drew this material together, pulling it into a spinning disk. This disk was a chaotic dance of particles, colliding and merging, driven by the relentless force of gravity. At the center of this disk, a star ignited, our Sun. This newborn star blazed with intense energy, its nuclear fusion reactions lighting up the surrounding space. Further out, smaller clumps of matter coalesced. These clumps, known as planetesimals, collided and stuck together, gradually growing larger. These planetesimals would become the planets. Through countless collisions and mergers they grew, their gravity pulling in more material. One of these nascent planets was our Earth. In its infancy, Earth was a violent, chaotic place, a world in the making. At first it was a molten ball of fire, bombarded by asteroids and comets. These impacts added to the heat, keeping the surface in a molten state. The heat was unimaginable, the surface a churning sea of magma. Volcanic activity was rampant, with lava flows and eruptions shaping the young planet. This was no place for solid ground, let alone life. The atmosphere was thick with toxic gases, and the surface was constantly reshaped by volcanic activity. Slowly, over eons, the Earth began to cool. As the heat dissipated, the surface started to solidify. The molten surface solidified, forming the first primitive crust. This crust was fragile and thin, easily broken by the ongoing volcanic activity. These were the very first rocks, the foundation upon which our planet would be built. They were the building blocks of the Earth's surface, slowly accumulating and forming a more stable crust. These early rocks were unlike any we see today. They were formed under extreme conditions, with a composition that reflected the violent environment of early Earth. They were primarily composed of dark, dense minerals, formed under unimaginable pressure and heat. These minerals were the result of the intense volcanic activity and the high temperatures of the young planet. These primordial rocks were constantly recycled, melted and reformed as the young Earth remained geologically active. Volcanic eruptions and tectonic movements continually reshaped the surface. Over time, these early rocks would be buried, transformed, and provide the raw materials for the incredible diversity of rocks we see today. The Earth's surface evolved, giving rise to the complex geology that forms the foundation of our planet's landscape. Deep within the Earth, even today, lies a fiery heart. This heart is not just a metaphor but a literal sea of molten rock known as magma that churns and flows beneath the Earth's crust. The Earth's mantle, a layer of molten rock called magma, is a place of intense heat and pressure. Temperatures here can reach up to 4,000 degrees Celsius, and the pressure is immense, enough to melt rock into a thick, viscous liquid. Sometimes this molten rock erupts onto the surface, a dramatic display of our planet's inner fury. These eruptions can be explosive, sending ash and lava high into the sky, or they can be more subdued, with lava gently oozing out and flowing down the sides of a volcano. When magma cools and solidifies, it forms igneous rocks, a testament to the Earth's volcanic power. This process can happen both above and below the Earth's surface, leading to the formation of different types of igneous rocks. Igneous rocks are categorized into two main types, intrusive and extrusive. This classification is based on where the rock solidifies in relation to the Earth's surface. Intrusive igneous rocks like granite cool slowly beneath the Earth's surface. This slow cooling process allows the minerals within the magma to crystallize over a long period, resulting in rocks with large, easily visible crystals. This slow cooling allows large crystals to grow, giving granite its characteristic speckled appearance. Granite is often used in construction and sculpture due to its durability and attractive appearance. Extrusive igneous rocks like basalt form when lava erupts onto the surface and cools rapidly. This rapid cooling process doesn't give the minerals much time to form large crystals, resulting in a fine-grained texture. This rapid cooling prevents large crystals from forming, resulting in a fine-grained texture. Basalt is one of the most common rocks on Earth's surface and is often found in oceanic crust and volcanic regions. Volcanic eruptions, while destructive, are also a creative force. They can reshape landscapes, create new landforms, and even influence the climate by releasing ash and gases into the atmosphere. They have shaped our planet's landscapes for billions of years, building islands and creating new land. Volcanic activity has been a constant force in Earth's geological history, contributing to the formation of mountains, plateaus, and islands. The Hawaiian Islands, for example, are a chain of volcanoes that rose from the ocean floor, built by countless eruptions over millions of years. Each island in the chain represents a different stage in the volcanic life cycle, from active volcanoes to eroded remnants. The very ground we stand on, in many parts of the world, is composed of igneous rocks, a reminder of the Earth's fiery past and ongoing dynamism. These rocks tell the story of our planet's formation and the powerful forces that continue to shape it today. From the depths of the mantle to the peaks of volcanic mountains, igneous rocks are a testament to the ever-changing nature of our world. While igneous rocks are born from fire, sedimentary rocks are the products of a slower, gentler process, erosion and deposition. Unlike the dramatic birth of igneous rocks from molten lava, sedimentary rocks tell a tale of gradual transformation, shaped by the persistent forces of nature over eons. Over vast stretches of time, wind, rain, and ice wear down existing rocks, breaking them into smaller fragments called sediment. This relentless weathering process is a testament to the power of natural elements, slowly but surely disintegrating even the hardest rocks into tiny particles. These sediments, carried by rivers, glaciers, or wind, eventually settle in layers at the bottom of lakes, oceans, or deserts. Each journey is unique, with some sediments traveling vast distances, while others remain close to their source, creating a diverse tapestry of materials. Over time, these layers of sediment are buried under more and more material. As new layers accumulate, they press down on the older ones, creating a record of geological history that can span millions of years. The weight of the overlying layers compacts the sediment, squeezing out water. This compaction is a crucial step in the formation of sedimentary rocks, as it reduces the spaces between particles, making the sediment more solid. Dissolved minerals in the water act as a glue, cementing the sediment particles together. These minerals, often carried by groundwater, fill the gaps between the particles, binding them into a cohesive whole. This process, called lithification, transforms loose sediment into solid rock. Lithification is a complex interplay of physical and chemical changes, resulting in the creation of various types of sedimentary rocks. Sandstone, formed from cemented sand grains, is a prime example of this process. Its distinctive layers and textures tell a story of ancient deserts, beaches, and riverbeds, where sand was once deposited and later transformed into rock. Sedimentary rocks are like pages in a history book, each layer recording a specific period in Earth's past. These layers can reveal information about past climates, environments, and even the movements of continents. Fossils, the preserved remains of ancient organisms, are often found embedded within sedimentary layers. These fossils provide a window into the past, offering clues about the plants and animals that once inhabited our planet. By studying these fossils and the rock layers themselves, geologists can piece together a picture of Earth's history, its changing environments, and the evolution of life over millions of years. This detective work involves analyzing the composition, texture, and arrangement of rock layers, as well as the fossils they contain, to reconstruct the ancient landscapes and ecosystems that have shaped our world. Geologists often venture into the field, exploring remote and rugged terrains to collect samples and gather data. Their work is crucial for understanding not only the history of our planet, but also for predicting future geological events and finding resources like oil, gas, and minerals. Modern technology has revolutionized the study of sedimentary rocks. Satellite imagery, computer models, and advanced laboratory techniques allow scientists to analyze rock formations in unprecedented detail, uncovering new insights into Earth's dynamic history. From the towering cliffs of the Grand Canyon to the white chalk cliffs of Dover, sedimentary rocks are found all over the world, each formation telling a unique story. These natural wonders not only captivate our imagination, but also serve as invaluable records of Earth's geological and biological evolution. The study of sedimentary rocks is a journey through time, revealing the secrets of our planet's past. Each rock sample, each fossil, and each layer of sediment adds a piece to the puzzle, helping us understand the complex and fascinating history of Earth. As we continue to explore and study these ancient rocks, we gain a deeper appreciation for the natural processes that have shaped our world. Sedimentary rocks, with their rich history and intricate details, remind us of the ever-changing nature of our planet and the stories it has to tell. The Earth's crust is a dynamic place, constantly shifting and changing. Deep beneath the surface, heat and pressure can transform existing rocks, both igneous and sedimentary, into something entirely new, metamorphic rocks. The word metamorphic comes from the Greek words meta, change, and morpha, form, aptly describing the transformative nature of these rocks. Metamorphism occurs when rocks are subjected to intense heat and pressure, but without melting completely. These conditions are found deep within the Earth's crust or where tectonic plates collide. The heat and pressure cause the minerals in the original rock to rearrange themselves, forming new minerals and textures. For example, limestone, a sedimentary rock, can be transformed into marble, a metamorphic rock prized for its beauty and durability. The intense forces that create metamorphic rocks often leave their mark in the form of folds, bands, and other striking patterns. These features not only add to the aesthetic appeal of metamorphic rocks, but also provide clues about the geological forces that shape them. Metamorphic rocks are a testament to the Earth's ability to transform and reshape itself over vast stretches of time,